All right, we are two-thirds of the way through the basics of hypothesis testing. We've done the beginning and the middle, the beginning being address the null and alternate hypothesis, and the middle being find a p-value, compare it to a significance level, and now we're ready for the end. The end, the last part of hypothesis testing is to state the initial conclusion, reject or fail to reject the null hypothesis, and the final conclusion in terms of the claim. Actually, we've already practiced the initial conclusion. We said if we got a p-value that was less than the significance level, we rejected the null hypothesis. If we got a p-value that was greater than the significance level, then we failed to reject the null hypothesis, and we never accept the null hypothesis. An important note: rejecting the null hypothesis is equivalent to accepting the alternative hypothesis. If the alternative hypothesis is your claim, then you've proven it. Failing to reject the null hypothesis doesn't prove anything. It simply means that there is not enough evidence to support or reject the claim. If you're conducting a study and want to use a hypothesis test to support your claim, the claim must be worded so that it is the alternative hypothesis. For example, to prove that the average age of Rome State students is greater than 21, our claim would be that the mean is greater than 21. The null hypothesis would be that the mean is equal to 21. That actually should have a mu in it. The alternative hypothesis would have to be that the average age is greater than 21. The claim would be that mu is greater than 21. That would be false if mu is less than or equal to 21. And if you rejected the null hypothesis, you would be accepting the alternative hypothesis, and that means you would have proven your claim. All right, the trickiest thing about the final conclusion is just learning how to express it in terms of the original claim. You have to be very clear on what the original claim is, what the null hypothesis is, and what the alternative hypothesis is. We're going to use this flow chart to help us word our final conclusions. It begins by asking, is the alternate hypothesis the same as the claim? If the alternative hypothesis is the same as the claim, then ask yourself, did you reject the null? And if you rejected the null, then that means you are accepting the alternate hypothesis. If the alternate hypothesis is the same as your claim and you accept it, then there is sufficient evidence to support the claim. If the alternate hypothesis is the same as the claim, but you reject it, then you have to say there's not enough evidence to support the claim. The other answer to is the alternate hypothesis the same as the claim could be no. They're different. The alternative hypothesis is not the same as the claim. When the alternate hypothesis is not the same as the claim, and you reject the null, you're accepting the alternate hypothesis, and that would mean there is sufficient evidence to reject the claim. You've rejected the null, you've accepted the alternate, and the alternate is not the same as the claim. That means there's enough evidence to reject the claim. And if the alternate is not the same as the claim, but you failed to reject the null, then that means there's not enough evidence to reject the claim. We're going to have to refer back to this flow chart until you get the hang of stating this final conclusion in terms of the original claim. So I'm going to hang on to this and show it to you again in a minute. Never conclude a hypothesis test with a statement, reject the null hypothesis or fail to reject the null hypothesis. That is your initial conclusion. But if you were to conclude an article in a scientific journal or just an article in a magazine with reject the null hypothesis or fail to reject the null hypothesis, nobody would know what you're talking about. Always make sense of the conclusion with a statement that uses simple, non technical wording that addresses the original claim. You either say there's enough evidence to support the claim, there's enough evidence to reject the claim, there's not enough evidence to support the claim, or there's not enough evidence to reject the claim. Those are your four possibilities. All right, some examples. Number 38, the original claim is that the percentage of on time U.S. airline flights is less than 75%. First thing to realize is that this is a claim about a percentage or proportion. So we're going to use the symbol P in our claim. P is less than 75% or P is less than 0.75. It didn't say less than or equal to. If the claim is P is less than 0.75, that's false if P is greater than or equal to 0.75. Remember, the equals either has to be in your claim or in this statement that makes your claim false. The alternate hypothesis is always the one of these two that does not include the equal. So in this case, the alternate hypothesis is the claim. P is less than 0.75. And the null hypothesis always has equals. So again, we have practiced the beginning of the hypothesis testing process. We've identified the claim, what made the claim false. The one of these two that doesn't have the equals is the alternative, and the null always has equals. If our initial conclusion is to reject the null hypothesis, when you see those words reject the null hypothesis, I automatically want you to think if you're rejecting the null, then you're accepting the alternative. And then ask yourself, is the alternative the same as the claim? In this case, you're saying that you have proven P is less than 0.75, and that's what your claim is. So you have proven your claim. Or looking back at our flow chart, the alternate hypothesis was the same as the claim. We did reject the null and accept the alternative hypothesis, and that means there's enough evidence to support the claim. So my final conclusion would be there is sufficient evidence to support the claim that, and then just restate the claim in the simplest way possible. The simplest way to state that claim is less than 75% of US flights are on time. Maybe passengers were complaining about delayed flights and they took their case to court. They claimed that less than 75% of flights were on time. They supported their claim. So perhaps there'll be some changes in airline policies that gets this rate of on-time flights raised a bit, or the rate of delayed flights down a bit. Number 39, the percentage of Americans who know their credit score is equal to 20%. Again, this is a claim about a percent or a proportion, so I'm going to use the symbol P in the claim. And this claim is that P equals 0.20 or 0.2. That claim is false if P does not equal 0.2. And the alternate hypothesis has to be the one of these two that does not include the equals. Therefore, the alternate hypothesis is P does not equal 0.2. The null hypothesis always has equals in it. Whenever the initial conclusion is failed to reject, that always means insufficient evidence or there's not enough evidence. So I'm going to start my final conclusion with those words. There is insufficient evidence the thing that you're going to have to practice is learning whether to say there's insufficient evidence to support the claim or insufficient evidence to reject the claim. Your alternate hypothesis was not the same as the claim. So looking at our flow chart, the alternate hypothesis is not the same as the claim, and we did not reject the null hypothesis, so there's not enough evidence to reject the claim. There's not enough evidence to support the claim either, but in particular, the folks who made the claim p equals zero point 0.2 were saying to them that there's not enough evidence to reject the claim that 20% of Americans know their credit score. All right, number 40, the percentage of Americans who believe in heaven equals 90%. Again, that's a claim about a proportion. P equals zero point 0.9. That's false if P does not equal zero point 0.9. That means the alternate hypothesis has the not equals and the null hypothesis has the equals. Whenever you reject the null hypothesis, I want you to think you're accepting the alternate hypothesis. Then the question becomes, is the alternate hypothesis the same as the claim? Are these two saying the same thing? They're not. We're accepting that this is true. The claim is that the opposite was true. So if we have accepted P does not equal 0.9, we have rejected the claim. There is sufficient evidence. To reject the claim that 90% of Americans believe in heaven. It may be more than 90%, it may be less than 90%. We don't know. But there was enough evidence to reject the claim that 90% of Americans believe in heaven. All right, let's practice this final conclusions a little bit more because it's tricky. What if the claim is that the proportion of female students at Rome State is greater than or equal to zero point 0.6? It's a claim about a proportion. The claim is P is greater than or equal to 0.6, and that would be false if P is less than 0.6 because those are complements of each other. The alternate hypothesis, and notice here I use the notation H1 instead of HA. I just mix those up sometimes because different books use different notation for the alternate hypothesis. But the alternate hypothesis has to be the one of these that does not contain the equals. That's P is less than 0.6. And the null hypothesis is always P equals 0.6. If we reject the null, that means accept the alternative then we're saying that P is less than zero point 0.6, and that is not what the claim says. If we're accepting that this is true, then automatically the claim is false, and rejecting the null hypothesis would mean there is sufficient evidence to reject the claim. And I don't have time or space to rewrite the claim. The proportion of female students at Rome State is greater than or equal to zero point 0.6. We're just kind of getting an abbreviated version of the final conclusion here. But since I'm accepting that I have proven P is less than zero point 0.6, that means I have disproven that claim. Failing to reject always means there is insufficient evidence for something. But to determine whether to write insufficient evidence to accept or reject, look at our flow chart for a second. The alternate was not the same as the null hypothesis, and I did not reject the null hypothesis. Therefore, there's not sufficient evidence to reject the claim. Notice when the claim and the alternate hypothesis are different, then your final conclusion is about rejecting the claim. Either there is sufficient evidence to reject it or there's not sufficient evidence to reject it, but neither one of these said anything about accepting the claim. Next example, the proportion of female students at Rome State is greater than 0.6. That's P is greater than 0.6. And that's false if P is less than or equal to 0.6. So the alternate hypothesis has to be the one of these that doesn't have the equals. That's the P is greater than 0.6. And the null hypothesis always has the equals. P equals 0.6. Rejecting the null always means accept the alternative. And so we're saying that this is true, and it's the same thing as the claim. If this is true, then that has to be true as well. So rejecting the null hypothesis and accepting the alternate hypothesis would mean there is sufficient evidence to support the claim. And failing to reject always means insufficient evidence for something. But let's go back to our flow chart. The alternate is the same as the claim. We failed to reject the null hypothesis, so there's not sufficient evidence to support the claim. And again, notice that if the claim and the alternate hypothesis are the same, then either of these final conclusions is addressing support the claim. If they're different, then we either have enough evidence or don't have enough evidence to reject. If the claim and the null are the same, then we either have enough evidence or don't have enough evidence to support. All right, two more. The claim is that the proportion of female students at Rome State is zero point 0.6. That's P equals zero point 0.6. And that's false if P does not equal zero point 0.6. So the alternate hypothesis would have to be the one of those that does not have the equals, and the null hypothesis always has the equals. Notice that in this case, the claim and the alternate hypothesis are not the same. So if we reject the null hypothesis and accept the alternate hypothesis, we're accepting that this is true. And if this is true, this must be false. So we're rejecting the claim. Failing to reject the null hypothesis always means there is insufficient evidence and again, if the claim and alternate hypothesis are not the same, then both reject the null and fail to reject the null have to do with rejecting the claim. Failing to reject the null would be there's insufficient evidence to reject the claim. And last, if the claim is that the proportion of female students at Rome State is not equal to zero point 0.6, if the claim is P is not equal to zero point 0.6, then that's false if the proportion does equal zero point 0.6. The alternate hypothesis has to be the one of these two statements that does not contain the equals. The null hypothesis always contains the equals. Rejecting the null hypothesis always means there is sufficient evidence for something, but to determine what there's sufficient evidence for, just ask yourself, is the alternate hypothesis the same as the claim? And in this case, yes, they are. So if this is what you're accepting and that is your claim, then there is enough evidence to support the claim. Fail to reject always means there is insufficient evidence. And if the claim and the alternate hypothesis are the same, they're the same, but we failed to reject the null, that means there's not enough evidence to support. All right. Rejecting the null hypothesis means accepting the alternate. If the alternate is your claim, you supported it. Failing to reject means there's insufficient evidence to either support or reject the original claim. On this last slide, I have a comprehensive outline or flow chart for conducting a hypothesis test. Seems like there are a lot of steps, but I want you to remember that they all can be broken down into what I've called the beginning, the middle, and the end. The beginning would be the first 3 steps on this flow chart. where we identify the specific claim to be tested and we put it in symbolic form. Then we give the symbolic form that must be true when the original claim is false. So we have the claim and what makes the claim false. Number three says whichever of these two statements does not have the equals, that's your alternate hypothesis. Your alternate hypothesis cannot have the equals, it can have a greater than or a less than or a not equal to. The null hypothesis always has an equals. So the beginning really all boils down to identifying the null and alternative hypotheses in step three. Steps 4, 5, and 6 are what I have called the middle of this process, and it's done entirely on the calculator. You identify the significance level alpha just from reading the problem, and then you identify the statistic that is relevant to the test and determine its sampling distribution. I didn't mention that so much. We haven't talked about how to do the specific on the test on the calculator, whether to use a one prop z test or a t-test. We will talk about that in sections 8.2 and 8.3, but this will just be identifying which function to use on the calculator. Test 6, the calculator will calculate for you a test statistic and a p-value. And then in step 7, you compare that p-value to the significance level. And you have begun the end of this process. If your p-value is less than the significance level, you reject the null hypothesis. If the p-value is greater than your significance level, you fail to reject the null hypothesis. And then step 8, restate the previous decision in simple non-technical terms addressing the original claim. Never end your hypothesis test by saying reject or fail to reject the null hypothesis. You need to say whether you have enough evidence or don't have enough evidence to support or reject the initial claim. And remember, this flowchart will help you with the wording of your final conclusion until you get the hang of it. This will lead you to the answer. There is sufficient evidence to support the claim. There is not sufficient evidence to support the claim. There is sufficient evidence to reject the claim, or there is not sufficient evidence to reject the claim. So you just need to write your claim in terms of the original claim, and you will have finished your hypothesis test. Section 8.2 has just been going over this beginning, middle, and end. In 8.3, we will do hypothesis test about proportions, and in 8.4, we'll do hypothesis test about means.